Hello, right now I want to answer the question of how we could graph this function y equals x squared cosine x natural log of x in order to help us solve question 1. Later videos we'll talk about how we could find the minimums, maximums, and zeros and store the values. But right now let's talk about how to graph. Now the first thing I want you to do for this exercise is change your calculator to radians. Right now this one is for the TI-83 and TI-84. They work pretty much the same. So in the mode, that's where you could find the place where you could change to radians instead of degrees. If we're graphing a trigonometric function is involved there, usually we'll use radians. So anyway, and there's a lot of other different options that we probably won't be bothering with most of them except for the radians and degrees part. Now, in the y equals, you see this y equals button up there, that's where we could put our function. So I will do that right now. It is x squared times cosine of x. Let's see the buttons I'm pressing here. Times natural log of x. Okay, so that's what we're gonna do first. Now, if you look at the problem says we're actually graphing on the range from get it in there. X going from 1 to 8, not including 1 and 8, meaning x is between 1 and 8, not including 1 and 8. That's interval notation, and that's what that would mean. So what I'm going to want to do is I'm going to want to make sure the graph is only in x values. I'm actually going to put it between 0 and 9 so that you have a little extra wiggle room on the outsides. So your standard window settings would look like that. I pressed the window button in order to change this. So what I'm going to do here is for x min, I'll put 0. For x max, I'll put 9. The x scale there, that's just telling you how often you'll see tick marks. So there'll be a tick mark for every one, which is fine. And for now, I'm going to leave the y's the same. And I do the x, you can see the y scale is 1 as well. So now if you click graph, we should see the graph. And remember, the whole goal of this problem is to find mins and maxes, okay? And right now you could see the graph gets cut off. So, we want to see more of the graph, kind of the main point. Now, we could certainly go back to window and make the y larger and smaller, but there's a few different zoom options that maybe would help us out as well. Right now, I'm going to, I press this zoom button here, and I'm going to go down to zoom fit. Zoom fit is kind of the calculator's best guess at what of the graph do you want to see. So it won't always work for us, but it's worth giving a shot. Now when I click on zoom fit, see this line in the top right corner that kind of shows that it's loading. And when I do zoom fit, you could see that we end up getting the graph looking like that. Okay, and from here we would certainly be able to find minimums, maximums, and zeros. I'll do that in another video, but just so you could see where you would find that functionality. Above the trace button you'll see a calc, so if you do second calc, it gives you all those different options, finding minimums, maximums, and zeros. And as I said, I'll do that in the next video. So let me exit out of here. Just get out of there. Okay, and go back to the graph. Now the other thing I wanted to point out with this graph is, if you look at this graph, you see right now a couple zeros, a local minimum, a local maximum, which we'll certainly look at. But then you see over here, the graph kind of almost looks like it's going directly along the line by 1 and 2. And that's really too close to call. We can't really see. What if there are kind of tiny wiggles that, because of the resolution of the screen, we, don't know what's happening? Well, we could actually zoom in there a little bit further, and the best tool for this is zoom box if you want to really key in on something. So if I press zoom, the first thing you see is Z box. That's going to be zoom box. So I press enter here, and what you'll see is you see this little triangle over here. Well, the idea is, not the little triangle, I'm sorry, this little cross over here. And what we want to do is, we're going to press enter at two different corners. Now, if I go directly to the left of one and just ever so slightly above it, I'm going to press enter. Okay? Now that's the first corner of the box. Now if you then scroll to the left and right, you could see I'm actually forming a box. But the main problem points where we really didn't know what's going on with the graph kind of happened in that 1 to 2 range. So I go slightly past 2 and once again go really, really close to the graph. And now if I press graph, again, my fault, I'm supposed to press enter. Let me do that again. Alright, so I'll do the box from the other side. I could do it from down here and press enter. Then I'll go up, go to the left. You can see I have the box right around the trouble point, and enter is what I want to press. Now when I press enter, you could see what happened. It actually zoomed in a lot closer to the area that was trouble. Now even with this zoom, you could see it's still a little bit troubling. And the interesting thing about this is it actually stays on that zoom box feature. So you could go zoom box again, or you could just once again press enter at two different corners. So remember, we had our X scale at 1, which means each of these tick marks represent 1. This is 1 and this is 2. So we once again want to go just to the left of 1, since that's what we're concentrating on. And I'll press enter. And then once again, I'm going to go down and just go, just right next to the line. Because this is the area, it looks like it's along the line, but it's doubtful that it just all of a sudden goes completely straight. So if I press enter now, we're even closer to the line, and if you look here, you could actually see that in between 1 and -2, we did have a local maximum that we couldn't find. Now just to quickly show you how you'd find this local maximum, we'll do more in the next video. If I go to second calc, I go to maximum. Okay, the left bound, you see that little blinking thing over there, right? A blinking thing. If I go to the left of the local max, you just press the arrow, go to the left. That's left bound button. That'll put you to the left of the local maximum. I press enter and you see this little triangle show up there. That triangle is telling you, okay, I know that the local maximum is somewhere to the right. Now you see the word, it says right bound. I just go to the right, go to the right, go to the right, make sure I'm to the right of the local maximum, and then I click enter. And you could see that, alright, we're looking for a local maximum that's trapped into between those two arrows. So for the last thing is it says guess. Well, you put your that blinking cursor thing, item, right around where the local maximum is, and you press enter again, and if you do that, you see it gives you the maximum right down there. Okay, so once again, that's how you could play around with the graph, zoom in, change your window to see what you want to see, which could be important. In the next video, I'll talk about how we can find minimums, maximums, zeros again, and how we could store values so we could answer questions 1 and 2.